Oh,
Check 1, 2, 3. Okay.
Everyone, good afternoon. Thank you very much for joining today's webinar on emission quantification tool. So before beginning, I would like to give you some brief instruction how to participate in this webinar. So if you look at the bottom function key at the Zoom monitor, you will see participants, Q&A, and sharing the screen, raise hands, recording, and then the interpretation. So if you have question during the presentation, please use the Q&A box to make up questions. If possible, we will provide the answer here. If not possible, we can also answer, try to answer as many questions as possible during the presentation period. And then during the discussion period, if you have also question, you can also raise your hands. We may not be able to give everybody's questions, but try to, yes, try to get your questions as many as possible. And then please allow us to record all our presentation as well as discussion during this webinar. And then finally, but not least, there is an interpretation function key here. So for those who want to listen the presentation in English, please click English, EN, Indonesia, Bahasa Indonesia, ID, click ID, please. For Thai language, please click TH. Okay, then you will be able to hear that language. The simultaneous interpreters are there in this webinar. So please choose a appropriate language that you can understand. Okay, let me pass the microphone to the moderator, Mr. Muhammad Akil, please.
Thank you, Miho. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, Sawadika. Allow me to welcome all our distinguished guests, speakers, and participants to the ITGT webinar on application of emission quantification tool, EQT for quantification of greenhouse gases, GHG, and short-lived climate pollutants in waste management. This webinar is a joint collaboration event organized by Center for INTGT Sub-Regional Cooperation and Institute for Global Environmental Strategies, IGs, Center collaborating with UNEP on Environmental Technologies, CCET. Allow me to share the objective of our webinar program today. The objectives, the means of the workshop today are namely to introduce applicants of emission quantification tool for quantification of greenhouse gas and short-lived climate pollutants emissions from MSWM sector, and to explore the potential application of equity in the INTGT region with technical training. And our expected outcome from this program, CIMT and IGCCET can work together with the interested cities in quantification for their greenhouse gases and SLCPs emission from MSWM, and will assist city in using the equity results to make appropriate decision on selecting appropriate technologies for future waste management. Before we proceed with the welcoming remarks, I would like to invite all participants to open your camera for us to have the photo session. Thank you. CIMT will guide on the photo session. Please switch on your camera, and we will show the INTGT way, the triangle like this. Representative from WG. I think Mr. Rajiv, your camera is not good now. Okay, thank you. Please show your ITGT way, and my technician will do the rest. 1, 2, 3. Another shot. 1, 2, 3. Thank you. And then please allow me to invite Pak Firdaus Dahlan, CIT Director, to give his working remark. Your floor is yours, Pak. Thank you.
Thank you very much, Pak Kir, for your kind word. Mr. Papik Kesabong, Director of Foreign Affairs Division, Office of the Permanent Secretary, Ministry of Natural Resources and Environment, Thailand, and Chair of MTGT Working Group on Environment. Dr. Prema Kumara, Jagat Dikela Gamara Lalagi, Director of IGCCET Japan, Ms. Mihoma Hayashi, Policy Researchers, IGCCET, Dr. Rajiv Kumar Singh, Policy Researchers, IGCCET, distinguished participants, ladies and gentlemen, very good afternoon. Assalamualaikum, Sawadika. So first of all, allow me to welcome you all to this important webinar, Application of Emission Quantification Tool, AQT, for quantification of GHGs and SLCPs from municipal solid waste management. Since we are still under the pandemic of COVID-19, I hope you are all in good health and wish the pandemic could be totally under control. Together, we are stronger. At this opportunity, I would like to extend my gratitude to Dr. Kumara, IGCC and IGCCET team, and also to my colleague, Mr. Papik Kesabong, Chairman of MTGT Working Group Environment, for being our collaborators for today's seminars. The key target, as mentioned by my colleague just now, the moderators, for this webinar is how to introduce AQT, or Emission Quantification Tool, to members of MTGT to quantify emission reduction from municipality solid waste management. This tool was developed by IGs in partnership with Climate and Clean Air Coalition. It is internationally recognized and has been used in many countries as well. Currently, we have a solid waste management pilot project assisted by IGCCET in Padang City, West Sumatra, Indonesia. Thank you very much for our colleague from IGCCET, for which IGCCET has also used this tool to quantify emission reduction from solid waste management. For MTGT, the tool as such is very important. According to MTGT vision, by 2036, MTGT is targeting at least 40 cities in MTGT Implement Green Cities Action Plan, or JCK. MTGT has developed a blueprint, what we call Sustainable Urban Development Framework 2019-2036, to accelerate the sub-region to attain the SDGs target. In the first action plan 2019-2023, the first year, during the first five years, MTGT is targeting GHG emission reduction by 2 million tons of CO2 per year. We will increase these numbers from year to year. That is the reason why IGCCET assistance to MTGT is of paramount importance for the sub-region. Our colleagues from CCET, of course, will share with us about the tool accordingly in the rest of agenda this afternoon. Finally, I wish you all have a fruitful discussion. And again, thank you very much for your kind attention. Over to you, Pak Hil. Thank you.
Thank you, Pak Firdaus. Ladies and gentlemen delegates, because just being informed that during our first photo session, there's still numbers of participants who couldn't switch on their camera. So I would like again to invite all of you to open your camera for us to have the second round of photo session. Please show your IMTGT logo like this, and then our technical team will do the rest. Thank you. One, two, three. One more time. 1, 2, 3. Thank you very much. Now I would like to invite Honorable Mr. Pavish Kesabawong, Director of Foreign Affairs Division, Office of the Permanent Secretary, Ministry of Natural Resources and Environment, Thailand, come Chairman of the IMTGT Working Group of Environment for the welcoming remarks. Thank you.
Thank you very much. Good afternoon, everyone. Mr. Fidas, Dr. Kamara, delegation from IMTGT member countries, representative from the SIMP, representative from IGSCCET, distinguished ladies and gentlemen. On behalf of Ministry of Natural Resources and Environment, Thailand, as the chair of the Working Group on Environment under the IMTGT, I'd like to extend my sincere gratitude to SIMP and IGSCCET for hosting the webinar on application of emission quantification tools for quantification of greenhouse gas and short-lived climate pollutants. We cannot deny that IMTGT sub-region has achieved a great leap in attraction, investment, innovation, economic growth in the recent years, whereas our sub-region still has been facing various environmental challenges. The vision of 2036 estimated that around 30 million people are estimated to move to city by 2030. As cities grow in numbers, spatial, extent, and in density, the environmental and ecological footprints increase. Uncontrolled urbanization also causes increasing amount of waste, which lead to increased level of pollution and greenhouse gas emission. Therefore, the Sustainable Urban Development Framework 2019 to 2036 has been developed, focusing on all dimensions of urban development. In particular, the greenhouse gas emission reduction goal target is to achieve net zero emission in the IMTGT sub-region. Today's webinar is a great opportunity for IMTGT member states to understand the application of emission quantification tool, or EQT, developed by IGES for calculating greenhouse gas emission from waste management and short-lived climate pollutants in municipal areas. This tool will be used to estimating emission aimed to guiding the identification to climate-friendly waste management option for city in the MTGT region, sub-region. On the occasion of Thailand assumption of the MTGT Working Group on Environment Chairmanship 2019 to 2022, we truly hope we would receive strong support and cooperation from MTGT member countries, SIM and IGES, so that we could continue work on implementation of green urban development activities in order to achieve IMTGT strategy and the vision of 2036. I hope that the webinar will success today, and our representative will gathering some knowledge from the IGSCCET to implement the related activity in your areas. So please stay safe, stay healthy. Thank you very much.
Thank you, Mr. Pavik, for the remarks. Now let me invite Dr. Prima, Director of the Center Collaborating with UNEP on Environmental Technology, to deliver the welcoming remarks. Thank you.
เศรษฐกิจ3ฝ่ายมากล่าวนิดหน่อยก็สวัสดีครับคุณ ฮาคิมแล้วก็ท่านผู้ฟังทุกท่านหวังว่าได้ยินผมชัดแล้วก็เป็นเกียรติอย่างยิ่งมากที่ได้มาร่วมในการประชุมวันนี้มาดูเรื่องของการใช้เครื่องมือ AQT ของการวัดปริมาณการปล่อยก๊าซเรือนกระจกและมวลสารช่วงชีวิตสั้นที่มีการจัดโดย IMPGT แล้วก็ IGS แล้วก็ CCET ก็ผมขอใช้โอกาสนี้ในการขอบคุณท่านประธาน CIMT คุณเฟอร์ดัส
Affairs Division of Ministry of Natural Resource and Environment, Thailand, and all our colleagues in IMT, GT, and IJCCET who work hard to make this webinar successfully started. I also want warmly welcome all our participants from the IMT, GT countries and the cities. So there is no doubt about the importance of having better waste and resource management in achieving zero carbon societies in Asia and the Pacific region. I know most of our national and the local governments today joined here have already committed and taken actions to move forward. We also find that a recent 6th assessment report of IPCC, Global Methane Assessment Report, and the recent Global Methane Pledge signed by more than 100 countries, including some of our countries at the COP26, acknowledging the importance of addressing methane emissions from the waste sector, including waste sector, to achieve the reduction of emissions. However, if we look at the official IPCC global reporting, only 3 to 5% of global greenhouse gas are recorded as from the waste sector. This shows because the narrow scope of the end of pipe waste sector was relatively looking at only the waste disposal as landfill site. But of these issues, IJCCT has developed a greenhouse gas emission calculation tool based on the life cycle assessment. We're looking at the bigger picture, including waste prevention, collection, transport, recycling, and recovery. If you're looking at all these factors of the waste management, we can find that it can be contributed to more than 10 to 15% of greenhouse gas emissions. In addition, there is now wide understanding the importance of addressing the short-lived climate pollutants, such as black carbon, particularly open burning of waste. Due to the lack of waste collection services and lack of awareness among the residents, we can see open waste burning happening in most of our cities. Even though black carbon is still not identified by IPCC as an emission factor, we are addressing these issues collectively with the Climate and Clean Air Coalition and develop a new tool we call Emission Quantification tool, which can measures both greenhouse gas and the black carbon and the short-lived climate pollutants. That is, if you add all these, including, so we can find it can be more than 50% to 20% emissions can be from the waste sector. In this regard, I think today's webinar is very important and also good for our participants to discuss and learn from this overall picture of the waste management and its emission from the waste sector. And I hope our cities and the national governments are actively participate in this session and learn and enjoy today's webinar. So thank you very much. Over to you, Mr.
Thank you, Dr. Prima Kumara, for the welcoming remarks. For the next agenda, let me invite Mr. Rajesh Kumar Singh, Policy Researcher at IGCCET, for the presentation and lead our webinar today. Mr. Rajesh, the floor is yours. Thank you.
Thank you very much. So let's I start with the presentation on application of emission quantification tool for emission of GHGs and SLCPs from municipal solid waste management sector at city level. So before we start with the main presentation, I would like to ask some questions to the participants so that we can understand more about today's participants. So could you please use the poll displayed in your monitor to answer the question? The first question we'd like to ask, which country are you from? So the options you can see in the poll, Indonesia, Thailand, Malaysia, and others. What's it, 9? Yeah. So could you please use the poll displayed in your monitor to answer the question? Okay, let's see the result. So we can see, so I think you all can see the results. So we can see that most of the participants are from Thailand, 44%. And then we have a lot of participants from Malaysia as well, followed by Indonesia. So thank you very much. And we would like to go for second poll. So the second question, which sector are you from? So could you please answer using the poll? Central government, provincial or local government, academia, research institute, private sector, NGOs, or others? Okay. So let me share the result. So a lot of our participants are from central government, followed by provincial and local government, and some of our participants are from academia, and some answered as others. So let's me also go for the third question. Does your country have climate change policy action plan strategy? So this helps us to understand about the action plan in your countries, especially like Thailand, Malaysia, and Indonesia. We can see that a lot of the answer is yes, we do. So I kindly request all the participants to please use the poll and answer the question. Okay, so let me share the result. So here we can see that a lot of participants, they say that yes, we do. So 95% they answer as yes, the country has climate action plan. Similarly, I would like to also ask the next question, which is about your city. Does your city have climate change policy action plan or strategy? It seems there are a lot of answers stating that no, we do not, even though we have national action plan. But it seems like a lot of cities, they do not have climate change policy action plan or strategy. So let me, and a lot of answers also states that they do not know. So let me share the results. Okay, you can see the result. It says most of the answer, it's like a answer from the participant. It states that yes, we do. However, there are also a lot of answers which is stating that no, we do not. So it seems we have a higher percentage of answers stating that they do have a national climate change policy action plan. However, we can see the percentage has decreased when we look into the city action plan. So hope in coming days, the city will work on this development of policy action plan, especially on the climate change. And also there are a lot of participants who also stated they do not know about it. Yeah. So now let's start with the presentation. So I hope a lot of you all know about Intergovernment Panel on Climate Change, IPCC, which was established in 1988 by WMO and UNEP. And it has currently 195 member countries. And usually IPCC assessment provides a scientific basis for government at all levels to develop climate change policies. And they underlie negotiations at UN climate conferences under the framework of UNFCCC. So now talking about the climate change conferences, the United Nations Climate Change Conferences, it's a yearly conferences held under the framework, UNFCCC framework, and they serve as a formal meeting of the UNFCCC parties. Especially you are well known about these conferences as COP. And recently we have COP26, and usually this helps in assessing the progress in dealing with the climate change. So now we are talking about two important negotiations, especially like Kyoto Protocol and also Paris Agreement we are going to talk about. And starting with the Kyoto Protocol, it was adopted with more than 150 signatories in 1997. And this protocol is a legally binding like emission targets for developed countries, parties, for the 6 major GHGs. So they are carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. So usually in this protocol, they try to adopt a market-based mechanism, such as emission trading, clean development mechanism, and joint implementation, JI. However, it was observed by UNFCCC and the parties of Kyoto Protocol that the emissions limitation commitments are not sufficient to stabilize the atmospheric concentration of GHG. So to stabilize the atmospheric GHG concentration, they thought they understood that they need further emission reduction. So to discuss this, there were a series of climate meetings which was organized under this UNFCCC as a COP. And in Paris Agreement, they came up with legally binding international treaty on climate change which was adopted by 196 parties in Paris in 2015, and they all agree that the future global warming should be limited below 2 degrees, preferably 1.5 degrees compared to the pre-industrial level. And so to achieve this long-term temperature goal, countries aim to reach global peaking of greenhouse gas emission as soon as possible to achieve the climate neutral world by mid-centuries. And by 2020, countries submit their plans for climate action known as nationally determined contribution, NDGs. So all under this framework or after this Paris Agreement, all the countries, they had the mandatory to submit these NDGs to the UNFCCC Secretary. So these NDGs, countries communicate actions they will take to reduce their greenhouse gas emissions in order to reduce the goals of Paris Agreement. And countries also communicate in the NDGs actions they will take to build resilience to adapt to the impact of rising temperature. So as discussed in the earlier slide, all the countries, they were obliged to report to UNFCCC Secretariat about their emissions target, their actions, especially for the GHG from all different sectors through their NDGs. So already Indonesia, Malaysia, Thailand, they have already submitted their first submission of NDGs in 2016, and they have also clearly identified the sectors, major sectors for the reduction of GHGs. So in the case of Indonesia, Malaysia, they have already identified waste as one of the major sectors. However, in the case of Thailand, still the different sectors has yet to be identified. And similarly, as Dr. Kumara, the director of CCT, already mentioned, that CCAC, Climate and Clean Air Coalition, it's a volunteer partnership of governments, intergovernment organizations, business, scientific institutions, and civil societies. They are committed to improving the air quality and protecting the climate through actions to reduce short-lived climate pollutants. So mostly CCAC is working with all different stakeholders, including different cities, countries, to reduce short-lived climate pollutants from different sectors, including waste sector. And Indonesia and Thailand, they are already CCAC member. Indonesia is CCAC member since 2017. Thailand is CCAC member since 2019. However, Malaysia still, though it is not a CCAC member, however, Penang City is a member of MSW initiative. This is one of the initiative of CCAC for the SLCP reduction. So now CCAC is going to launch new initiative on reduction of SLCP from all sectors. They call them as a hub. So Waste Hub is one of the initiative where they look into waste sector for the reduction of SLCPs. And in February, they are going to launch this Waste Hub. So usually CCAC, when they are working with the countries or city, the countries and city, they are usually reporting or communicating the reduction target, reduction activities to CCAC. So hopefully after this launch of Waste Hub, more concrete plans for proper estimation, verification, monitoring, and reporting for SLCP will be introduced for reporting to the CCAC from the member countries, CCAC member countries on SLCP reduction from waste sector and also from different other sectors. So again, going back to the quiz, I would again like to ask the participants about, have you ever heard about short-lived climate pollutants, SLCPs, before? So could you please, can you see the poll in your monitor, in your screen? So it seems a lot of participants, they do not have, like they haven't heard about SLCPs. So hopefully, like today's presentation, we will be talking about SLCP and hopefully they would get some idea on SLCP. So thank you very much. And let me go for the next question, quiz 2. So which country have to communicate on SLCP to CCAC, Climate and Clean Air Coalition? So So a bit while ago, we discussed a bit about this communication to CCSE. So all three countries, it seems a lot of participants, they choose the option, all three countries. And yeah, 26% they choose Indonesia and Thailand, and 7% they said Malaysia and Indonesia. So the correct answer is Indonesia and Thailand at the moment, because they're all like CCSE members, and hopefully Malaysia is also going to be a CCSE member soon. And in that case, yeah, then I think all three countries, they will be going for the communication of their SLCP to CCSE. Yeah. Hopefully you can see the results. So most of the answers was all three countries, but the correct answer is Indonesia and Thailand. Yeah, thank you. So let me proceed. Sorry. Okay, so why this is so let me continue with the presentation. Now, as you know, that there are a lot of emissions of GHG as well as short-lived climate pollutants from municipal solid waste management, and the major GHG emissions from municipal solid waste management are carbon dioxide, methane, and nitrous oxide. Whereas talking about the SLCP, the major emissions are methane and black carbon. Greenhouse gases and SLCPs, such as black carbon emissions from waste management activities and its contribution to climate change, is one of the critical environment concern. And as shown in this picture, each and every step of waste management emits both GHGs and SLCPs. And final disposal is the most critical stage, especially in developing countries. Primarily disposal methods like open dumping and unplanned landfilling create a huge amount of methane emission. Therefore, cities need to undertake a rapid assessment of these emissions and identify suitable alternative solutions in order to develop climate-friendly waste management. And also, as shown in the previous slide, as now cities, they are like, they have a mandatory for quantify their emission and report to the national government, for especially reporting to their NDGs to the UNFCCC's secretariat. Similarly, that is for the GHG, and also for CCSE countries, member countries, they would like to quantify the SLCPs from different sector, including waste sector, and report to the national, so that the national can report to the CCSE. So now many governments have been promising and setting goals to achieve zero emissions by 2050. And mostly they are working on quantification and reporting of their emissions from all sectors to UNFCCC Secretariat. However, addressing long-lived climate gases such as carbon dioxide alone is not enough. So addressing short-lived climate pollutants like methane, black carbon is also equally important. So considering the impact of SLCPs on climate, it is being now discussed in IPCC technical group for its inclusion as a potential gas agents for climate change, such as GHG. And according to the recent global methane assessment, reducing human-caused methane emissions is one of the most cost-effective strategies to rapidly reduce the rate of warming, and also contribute significantly to the global efforts to limit temperature rise to 1.5 degree to 2 degrees Celsius. So improving waste management is critical to address methane and also this is third largest source of anthropogenic methane emission globally due to dumped and landfill organic waste. And especially you might know that in developing countries, over 50% of municipal solid waste is organic. And landfilling and improper waste management of these organic waste makes up about 20% of global anthropogenic methane emissions. So human activities is causing methane concentration to rise rapidly, threatening the achievements of global climate targets. And this increase is driven by three anthropogenic sources. They are like fossil fuel, agriculture, and waste. So current concentrations are well above the 2 degrees Celsius scenarios, which you can see from this slide. And also this was also reported by IPCC 2013 assessment. So from this slide, which was abstracted from Global Methane Assessment Report recently published, what we learned that the methane mitigation from the waste sector is also very important to limit the global warming to 1.5 degrees Celsius. Here you can see that methane emission need to be reduced from the waste sector is estimated about 30% to 35%. And it is by 2030, so that the global warming can be limited to 1.5 degree to 2 degrees Celsius. So we have another quiz which we'd like to open for the floor. So this is about, is methane GHG or SLCP? So your option is GHG, SLCP, and both. So could you please kindly use the monitor, the poll in which is displayed in your monitor to answer the question. So I can see a lot of answers, especially a lot of participants, they are answering both, followed by GHG, and the last one, the answer we can see, the less percentage of participants, they're answering SLCP. So you can see the answers, 86% they answer both. So that is the correct answer. So methane is both as GHG as well as SLCP. So thank you very much for your answers. Let us continue with the quiz. We have another quiz. So it says that the atmospheric concentration of the methane is increasing faster now and then at any time in the observational record. In order to limit the temperature rise within 1.5 degrees Celsius, how much percentage of methane needs to be reduced by 2030 from the waste sector? So just now we discussed this. I hope our participants can answer this question. So we are talking about the percentage of methane need to be reduced from the waste sector. So yes, a lot of answer we received. It says 30 to 35%. So yeah, that is the correct answer. 30 to 35% based on the methane assessment report recently published. So thank you very much. I think a lot of our audience, they had correctly answered the question. So let us move to our presentation. So here in this slide, we are discussing about short-lived climate pollutants. As a lot of our participants, it seems that this is the first time they are hearing about these short-lived climate pollutants. So the short-lived climate pollutants, they are powerful climate forces. They are responsible for up to 45 degrees of the current global warming. So to name with, like they are black carbon, methane, tropospheric ozone, and hydrofluorocarbons. And they remain in atmosphere for a much shorter period of time than carbon dioxide, but their potential to warm the atmosphere is much more higher compared to the carbon dioxide. And they are also dangerous air pollutants that have harmful effects for people, ecosystem, and also agricultural productivity. So you can see in the screen, you can see that for the black carbon, it has been stated 900 times much potent than CO2. Similarly, for the hydrofluorocarbon, you can see 1500 times in average, and also methane 84 times. This is over the 20 years period of time. And as we discussed that it has impact on like human health, agriculture, and also that atmosphere or the environment. So the two major black carbon which usually gets emitted from waste sector are black carbon and methane. So black carbon usually these are produced due to the incomplete combustion of fossil fuel, biofuels. And also, as we discussed, that a lot of like open burning of biomass usually takes place due to improper waste management. So that also emits black carbon. Similarly, methane, it's usually emitted when the organic component of the waste is improperly dumped, especially that is very common in the case of developing countries. A lot of organic waste that get mixed with the normal household waste, and it gets dumped into the final disposal site. So this generates a lot of methane. Similarly, when biomass are burned, when this uncollected biomass, when sometimes there is no proper collection system, and people tend to burn that biomass either in their backyard or on the roadside and so on. So this also emits methane. And there are other SLCPs such as SFCs and tropospheric ozone, especially SFCs, the industrial chemicals used in the air condition, refrigerators, solvents, fire extinguishing systems, and aerosols. So a lot of those equipments, they do have emits these HFCs. Similarly, like a tropospheric ozone, usually when the sunlight, UV rays, when they react with carbon monoxide or nitrogen oxide, they usually O3, that is tropospheric ozone, is generated, and it's a major component of urban smog as well. So this black carbon that has impact on climate, health, agriculture. So reduction of SLCP emissions has the potential to reduce the amount of warming by as much as 0.6 degrees Celsius. And when you talk about the health, nearly 7 million people die every year from the indoor and outdoor air pollution, especially tropospheric ozone and PM 2.5, where SLCPs are largely responsible for that. And talking about agriculture, tropospheric ozone exposure lower the yield by 12% for wheat, 16% for soybean, 4% for rice, and 5% for maize. So through the collection of landfill gas over the recovery of methane emissions has the potential to avoid the annual loss more than 50 million tons of crops. And similarly, when black carbon, if they deposit on the leaves of the crops, they disturb, they absorb more heat, and they disturb the photosynthesis of the crops, and destroying their growth, and then finally the plant dies. So in that way, the black carbon and other SLCPs, they have a greater impact to the products, especially the agricultural products. So SLCPs in waste sector, waste is a significant source of SLCPs, especially methane and black carbon, as we discussed earlier, and 40% of waste is said to be openly burned globally. So this data we got from CCAC website, and Open burning and use of polluting collection vehicles emit black carbon. So as we earlier discussed, like when the fuel are not properly burned, especially any old vehicles, especially old machineries used in the waste sector, they are the major contributor of this kind of like short-lived climate, especially the black carbon. So the solutions for this problem are like, especially when we improve waste collection. So this helps in minimizing the waste getting dumped into the environment. So the proper waste collection is very important. It helps in reduction of the waste which is polluting the environment. Similarly, the increase in material recycling, which helps again in reduction of valuables getting into the landfill, such as metals and plastics, and also organic waste diversion, which is a major emitters for methane. So when we properly divert the organic waste, either we use it as a inputs for the biogas or also for the composting facilities. So this helps only the inorganic waste or the residual waste to go to the landfill. So this reduce the methane emissions at the final disposal site. Similarly, landfill gas capture and use. So capturing landfill gas at the final disposal site helps in the prevention of methane emissions to the environment. So open waste burning, especially the burning usually takes place especially when we discuss in the waste flow, especially two areas, the open burning usually takes place. One is at the when the waste is not properly collected. So at the household level or the generation level, where the waste, if the city does not collect the waste, that waste gets either they burn around their area, or when the waste is sent to the final disposal site, and sometimes they burn at the final disposal site to reduce the volume, or also sometimes automatically, like due to the emission of methane and so on, there is automatic open fires in the landfills. So now we'd like to again ask a question. So what are the sources of black carbon emission from the waste sector? So the answer could be multiple answers. So the options are burning waste, burying waste, dumping waste at open area, transport of waste, composting, and incinerator. So we kindly request our participant to answer the question. I can see a lot of participants, they are answering burning waste. So the correct answers is, yeah, of course, burning waste. Also transport of waste. So usually when you use vehicle, they also generate black carbon. When you use fuel and when the vehicles are old, again, like it depends if they generate more or less. It depends on the vehicle. If the vehicle are new, the generation of black carbon is less. However, if the vehicles are old, they generate more black carbon. And also incinerator, again, it depends on the incinerator. If it's a well-equipped, it has a proper filter and so on. However, yeah, incinerator also generates the black carbon. So yeah, incinerator, transport of waste, and burning. These are the areas or the sources of black carbon emission in the waste sector. So thank you for your answers. I think, yeah, the audience are very much active in answering questions. That's really good. Thank you for your kind cooperation. So now I would like to introduce the emission quantification tool. So to address the emission problem or how to quantify the emissions from the municipal solid waste management sector, to address this, CCET, IGS developed this EQT, emission quantification tool, in cooperation with CCAC, Climate and Clean Air Coalition, which not only help to quantify the emissions for only GHG, but also the SLCP. So this tool also helps in quantifying both GHG, greenhouse gas, as well as short-lived climate pollutants. So some countries, they are only interested in quantification of GHG. So that's totally fine, because this tool will help you, this tool gives results for both the emission, GHG, as well as SLCP separately. So whatever, based on your need, you can use the results. For example, if you are looking to report to your NDGs, only you are looking for the GHG emission. So you can only look into the GHG, emission from the GHG sector. However, if you are looking for reporting to the CCAC, so again, SLCP emission, you would like to look into the SLCP emissions only. So based on your need, based on your priority, you can use the emission results. So this tool helps you in planning, monitoring, and proper technology selection. So we'll discuss more about this. So emission quantification tool, this is a decision-making tool, and it has a user manual which provide a stepwise guidance to the user to use the tool. And it also helps in a monitoring of your activities, as you can develop a current scenario based on the business as usual. However, based on the plans of the city on the climate change and also on the waste sector, you can develop a future scenario. Like if you have some kind of short-term, mid-term, long-term targets, so or the long-term activities based on your strategy, city plan or strategy, then you can develop a short-term, mid-term, and long-term scenarios, and you can compare the emissions. And also, based on the activities being implemented on the ground, you can monitor the progress. So this kind of options are available when you use this emission quantification tool. So this keep records and also monitor the progress made on the mitigation of GHG, SLCP emissions from sewage and waste management options. So based on what kind of plans you have and how much emissions you are trying to reduce, you can look into the areas where more emissions are being made, and you can choose the appropriate technology to reduce that emission in line with your plan. So now talking about the features of emission quantification tool, EQT is a simple and step-by-step guidance has been provided to the users in all seats on how to enter the data and obtain results. And if the user are well known with their Excel skills, then they do not have to have a special skill. They can easily operate this EQT, and each and every sheet has a designated way that user can easily move from one sheet to another. And this tool, as I mentioned earlier, this counts both SLCP as well as GHG from the waste management sector, considering the life cycle approach. So here, by life cycle approach, what it means that a lot of times it looks the tool also look into the saving potentials. For example, if you are recycling metals or plastics, then you are saving the resources, which either you have to use it from the ore, like a lot of energy, a lot of emissions would have been emitted when the metals is abstracted from the ore, or the plastic is abstracted from the oil resources and being processed. So this process we are avoiding when we are recycling the materials. So in that terms, we are saving that energy, we are saving the resources. So that amount, like that savings in terms of energy, in terms of resource, that gets added to this system. So a lot of times when you do more recycling, the results are in negative. So that is due to the saving potentials. So both emissions and saving potential is accounted across the life cycle. So what does the result of equity shows to the users? So the waste flow from the generation to fed. So from generation to the final disposal site, you can see how the waste, like how much is going to the composting, how much going to recycling. So how the waste travels. So from the generation to the final disposal, we can track the waste. So through the waste flow. Another is potential climate impact caused by GHG and also the SLCP, that is black carbon from the waste management sector. So in terms of either per ton of waste or like yearly generated waste. So you can choose the units according to your preference. And estimate emission of GHG and black carbon from each waste management activities. Yeah, so through like a individual process, also you can see how much emissions is being taken place through the waste management. For example, like emission from transportation or composting or recycling, or from the open burning of uncollected waste, or from the open dumping or incineration. So I would like to show an example from the Padang city where we have been recently working. So business as usual scenario for Padang city. Here you can see the total waste being generated, and also this is the waste flow where you can see how much is being collected and also how much is recycled and so on. And then also there is an informal sector where some amount of waste is being informally recycled, and very small amount is being sorted and recycled at the waste bank. And there are several emissions of methane, black carbon, and so on. So when we look into the emissions, potential emissions from the waste sector of Padang city, yeah, in this slide here you can see that the total emission for the GHG, here you can see more than 900 kg CO2 equivalent per ton of waste generated is being emitted. This is in terms of per ton. So per ton of waste, this much amount of GHG is emitted. And similarly for the black carbon, you can see about 47 kg CO2 equivalent per ton of generated waste is being emitted in the Padang city. And similarly, we look into the emissions in the yearly generated waste terms in Padang city, and here you can see the total emissions more than 224,000 tons CO2 equivalent of GHG is being emitted in per yearly generated waste in Padang city, whereas 11,000 tons CO2 equivalent per yearly generated waste. From the per yearly generated waste, the black carbon is being emitted. So if you look into the potential climate impact, 95% it's coming from the GHG emission, and on 5% from the black carbon. However, as we also discussed earlier, that the impact from the short-lived climate pollutants is much higher compared to the CO2. So when you look into especially black carbon, what we can see that the short-term impact, though it is short-lived climate pollutants, it has a much more higher potent, it's a higher potent gas compared to CO2. So sometimes based on the literature, you can find that more than 200,000 times it is more potent than CO2. So it has a higher impact on climate as well as health and also the agriculture industry. So now looking into the GHG emissions for different activities in the waste sector. So here you can see mostly the emissions of GHGs taking place from the open dumping area sector, and also from the open dumping and burning of the waste from uncollected waste. So usually the final disposal site, as the final disposal site is open dump, where like a mixture of both organic and inorganic waste takes place. So a lot of GHG emission takes place. And also similarly, uncollected waste, when it is dumped in the environment, again, it's also a mixture of organic and inorganic. So this also emits more GHG. And as I mentioned earlier, like you can look into the recycling part, it is in negative because of the saving potential. So as it recycling helps to replace the activities which would have been taken place to create those materials, for example, plastic or metals, if recycling would not have been done from the scratch. So we save those energy and emissions. So in that context, like the system, they account that saving as a saving potential. So now talking about the BC emissions from business as usual scenario, here you can see mostly the burning of uncollected waste emits the highest amount of black carbon, and also the transportation. So transportation and open burning are the higher emitters of the black carbon. This is in terms of per ton of generated waste. So how do you use the result of EQT? So especially you can use it, especially to quantify how much emission, like to get the quantitative analysis of the emission. So the EQT can be used to it gives you the quantified terms of the emissions in GHG as well as in the terms of SLCPs. For the waste sector, it is for the black carbon. So this helps also shows you which sector is emitting more GHG or black carbon. So in that case, you can also look into how to reduce the GHG or black carbon in from that waste management that particular activities, and choose appropriate technologies or appropriate methods to reduce the emissions. And also based on your business as usual scenario, you can again develop your future scenario in line with your strategy or your plan. So we used this emission quantification tool along with the CCAC, Climate and Clean Air Coalition, to assist Philippine government to develop a national strategy to reduce short-lived climate pollutants from municipal solid waste sector in Philippines. So this action plan was developed in 2019 and adopted by the government, and now the activities in the action plan is being implemented in Philippines. So you can see some of the reports which were developed during the development of this strategy. And the fourth one with a blue cover, that is the cover page of the strategy. And the last one you can see at the end, the one of the publication which was made based on the results obtained from our study during the development process of this national strategy on SLCP. So we published this in Waste Management Journal. So this all like especially the results was obtained from the national strategy and our study in the pilot areas in the Philippines during our development process. So just to highlight some of the main strategy which was highlighted in this Philippines national strategy on SLCP. So the Philippines national strategy, they came up with two main strategy for CH4, that is methane reduction. And you can see here in this slide, they have targets, especially the baseline was 2010. However, they have targets for 2025, 2030, and 2040. So 2025 is a short-term target, mid-term target 2030, and 2040 is the long-term target. And they have for each activities, they have percentage, how much percentage they would like to reduce or make the diversion or so on. So based on your like a target year, they have like percentage in each activity. Similarly, they also have a strategy for BC reduction, that is black carbon from the waste sector. So they have like 5 strategy for black carbon, and similarly they have like targets and short-term, mid-term, long-term goals, and each activity has the percentage. So now, based on the targets and the activities, we try to again look into the emissions, how much reduction they can make based on the implementation of the activities which are they are thinking in short term, long term, and mid-term strategy. So if the Philippines, if they like you can see the 2010 is the business as usual year, where they're producing 5 million tons of CO2 equivalent from the total generated waste. So if the Philippines, they implement their short-term like targets, all the activities in the short term in line with the whatever targets they have set for the short term for both GHG as well as black carbon, that is short-lived climate pollutants, they can reduce 32% reduction from the business as usual. Similarly, if the midterm they implement on the ground, they will reduce 48% reduction in GHG and SLCP. And also for 2040, they can reduce 56%. So that is their long-term target. So if they are able to implement the long-term target, they will reduce more than 50% of emissions from the waste sector. So now I will again like to get back to the quiz. So maybe I hope you all are not sleeping. So let's have a quiz 6. How could the scenario be used? So let me share the poll with the participants. I can see a lot of participants answering or going for the like a fourth option, all of the above. And yeah, so let me share the result. I hope you can see the result. So the answer, the majority of 73%, they answered that all of the above, and I think they are correct. So this 73%, yeah, all of the above is the correct answer. Yeah, this IQT or this scenario helps, especially in the monitoring of emissions and also selection of best options. When you are looking into scenario development, you are looking into the options, especially best options, to achieve that like a scenario. And also enhancing the capacity of waste management, of course, when we are implementing the activities in line with the scenario, you automatically enhance the capacity of the waste management. So thank you very much. So now let me go for the conclusion. So GHG and SLCP mitigation helps in reduction of global warming, avoids the premature death, and also avoids the loss of major crops. So as you have seen from this presentation, that both GHG and SLCP has impact on health and also on environment and also on agricultural activities. So when you reduce that, automatically you'll have you'll reduce the impact on these areas. So to keep the Earth increasing temperature below 2 degrees Celsius, the measures to mitigate SLCP emissions, along with the measures to mitigate GHG emission is essential. So of course, only GHG alone, like looking to only the GHG mitigation of GHG emission alone is not a very strategic way to look into or to help all the effort, especially the global effort to reduce the temperature below 1.5 to 2 degrees Celsius. So SLCP, as it has a huge impact, though it is a short-lived climate pollutant, but it has a huge impact, it is much more potent gas than CO2, and it has huge impact on global warming. So considering SLCP is also a very important aspect when you are looking into like a goal to reduce the global temperature to reduce below 1.5 to 2 degrees Celsius. So the last point, special equity enables cities to estimate and communicate GHG and SLCP emissions from municipal solid waste management sector to national, and it's helpful in communicating to like those who are already communicating to NDGs. So this will help to communicate the GHG emissions from waste sector for their NDGs, and also those who are the CCSE member countries. It helps you to communicate SLCP emissions from the waste sector to CCSE. So this is all from my presentation, and if you have any questions, we can open the floor for the question and answer. Yeah. Thank you.
So please raise your hand if you have questions. Who can I see who has? Okay. Can you control? You see who? Irawan.
Can you see the presentation screen?
Okay, Mr. Irawan Asad, do you have question?
Okay, can you hear me?
Yes.
Okay, thank you. Thank you. Good afternoon, everybody. I'm Irawan, and I'm responsible for the greenhouse gas inventory in Indonesia. And today we are accompanied by my colleagues, Alan Kosehan and Ruli, who are responsible for the waste sectors. So first of all, I want to thank to the IMT and the Center for Indonesia, Malaysia, Thailand Growth Triangle, and the IGS for hosting this event. It is really nice to see you all and then to discuss with your tools. Let me give you a bit introduction of Indonesian greenhouse gas inventory on waste sectors. That Indonesia has submitted the updated NDC on 2021. On that updated NDCs, Indonesia aimed to reduce the greenhouse gas by 29 to 42% by 2030. Along with the NDCs, we also submit the LTS LCCR, where we aim to reach a net zero emission by 2060 or sooner. Within that NDC, the year target for the waste sectors is about 3.38 to 1%, or to achieve a level of greenhouse gas on 285 to 270 million ton CO2 equivalent on 2030. And based on our inventory report on 2021, waste sectors contribute to around 12.07% of national greenhouse gas inventory. However, this level is lower than the BAU, business as usual, and CM1 scenario. And this decreased 5.1% compared to the 2020 level. The main source of greenhouse gas are coming from industrial wastewater treatment and discharge, unmanaged solid waste disposal, and domestic wastewater. Here, we thank to the Center for introducing tools to improve the quality of greenhouse gas data on waste sectors. And you might be aware that we have a national system for the greenhouse gas inventory that can be accessed online. We call the system Science Smart, and we developed the system since 2006 using IPCC guidelines 2006 and its refinements. We developed the systems in 2005, and this is the backbone of our of our inventory, national inventory, and to develop a report such as BOR. We just submitted our third BOR on 2021, National Communication and FREL report. Therefore, we are keen to learn more and discuss about your EQT tools, emission quantification tools. We are keen to understand, is it compatible with our system, and how to use the tools as an add-ons to our national system to collect or to improve the quality of waste data. Thank you.
So, thank you very much, Mr. Asad. And it is nice to learn, especially already Indonesia, they have already submitted their NDGs, and also it's good to learn that they already have a national system. I think it's known as Science Map, and yeah, it's also developed in line with the 2006 IPCC guideline. So I would also add up, I'd like to let you know or highlight that our EQT, so it's also like developed in line with this 2006 IPCC. Like we also follow the 2006 IPCC guideline for national greenhouse gas inventories, and a lot of our emission factors and default values, especially it comes from IPCC, and also published papers and results, and also some of the outcomes based on our work in different countries. So we have used those values, especially for during our development of this EQT tool. And I kindly request you, especially you give us a different data, especially national reduction target, as well as also the target, especially from the waste sector. So if it would be really good if you can kindly share with us those targets and already committed. And I also learned that 5% reduction was also achieved from 2020. So this was for the waste sector.
Yeah.
So Mr. Asad, it would be good that we can have a separate meeting to discuss how our tool can be incompatible with the tool being used by Indonesia, and how we can use or how the cities in Indonesia can use the tool, especially for emission quantification. So we are very keen to discuss and also use this tool for the Indonesian cities. Yeah, thank you. And then if possible, we'd like to get that especially the information, especially the targets and committed by the Indonesia, especially for the waste sector. If we can, if you can request someone to share that with us, that would be really helpful. We'd like to look into those targets and the activities which has already been done to achieve this 5%. Yeah, thank you.
You might find the target on our NDCs, updated NDCs, the document. And you also can you may also access our latest BOR on the UNFCCC portal. So all of them are available in that one. We're also keen to discuss with you how your tools can be compatible with our system, and maybe we can have like a kind of toolkit for our system as well. Thank you, Kumar.
Yeah, thank you very much. So let's have separately we can organize a meeting, and then we can discuss about this. Yeah. Thank you, Dr. Arsa. So, Mr. Arsa.
We receive another question in the Q&A box. Do this EQT in line with IPCC 2006 methodology? We already answered. Yeah. Yes, it does. We have targeted our NDC using IPCC 2006 tools. So how can we track our NDC progress with EQT? Which is similar question as the previous one.
Yeah. Where is the question? Which one?
Q&A.
Oh, yeah. do this equity in line with, we have targeted our NDG using IPCC tool. So how can we track our NDG progress with equity? So yeah, just to answer this, Mr. or Ms. Ruli. So yes, this like our tool, as I mentioned earlier, this is in line with IPCC 2006 methodology. And yeah, so using this equity, we first we can develop the business as usual scenario, and whatever like activities you have, like whatever target you have made, like made for to achieve by 2030. So that can be like your like future scenario. So based on that, like you can have like different activities to achieve that target. So in that way, whether that activities is being implemented or not, and whether the emissions from that activities is like being reduced or not. So you can use that like business as usual scenario to compare that, and whether we are reaching to us achieving the target or not. So that kind of like monitoring can be done. Like you can compare the business as usual and your future scenario, and then you can monitor the progress. Yeah.
There's another question coming.
For methane avoidance in landfill, Indonesia used the first order decay method. Emission occurs from the mass accumulation of DDoC in the landfill. From the So one thing, yeah, like when we look into the IPCC and EQT, so especially when we look into the EQT, we look into the overall holistic approach. So it's like it is looking into life cycle assessment approach. So from cradle to grave. So what are coming in the system, and what is coming out of the system. So it's looking as a overall approach, not the separate approach, like for example, emissions from the composting or emissions from the landfill. So it's like an overall approach. Whatever like you include, especially the EQT has the key data sheet. So whatever you include in the key data sheet, so that key data sheet, especially for example, you put total like a generation amount, and out of that there is another different slot where you have to put total generation amount, and also how much out of that like total generation amount, how much is being collected, so total collection amount, and how much is being informally recycled. And in that same like a sheet, you have like composition of waste, and how much is go to the composting, how much is being recycled. So whatever you put into the key data sheet, automatically it goes to the separate like a data sheet for composting, recycling, landfill. So whatever, like, so this prevents double counting, as well as in this case, this also includes transportation. Usually when we are like when you are looking into the waste sector, a lot of times we don't include transportation, because it goes under the transportation sector, especially when in different countries. Usually transportation like for the transportation of waste goes under the transportation sector. So we don't put usually the countries, they don't put the transportation of waste into the like waste sector. However, in the EQT we include that. So whatever like emission is coming from the transportation of waste, it is also included. And also like whatever emissions when you are processing the composting, whatever emissions it's coming from the recycling, and also from the incineration or landfill, everything is being counted, and as a whole the overall total emission is calculated. So something like that usually. So we have also invited some of our previous, like some of participants who have already obtained the training, EQT training, especially from Thailand, Nonthaburi city. We have Jirapon. I hope she is also participating in today's webinar. If she is there, we'd like to invite her. Miss Jirapong, are you there? Can you raise your hand if you are there? Okay, she's there. So can we unmute her? So we would like to hear her experience using EQT. So let's invite her. Yeah. Hello, Miss Jirapong.
Hello.
How are you?
Yes, I'm here.
Yeah. Yeah. So we kindly request you to share your experience using EQT, especially you attended our first training, regional training on EQT, especially to quantify the emissions from Nonthaburi city.
Yes, from my experience to use EQT equipment, in Nonthaburi we plan to select the transportation to reduce greenhouse gas and emission from transportation and solid waste disposal in landfill, because now every municipality in Nonthaburi, we send the garbage to the landfill site of provincial, Nonthaburi provincial to disposal. And after I come back from Philippines, I use the experience for this EQT to plan and reduce this gas too.
So you use the EQT result to plan, especially the transportation,
processing, and final disposal, because now in Nonthaburi we plan to operate the incinerator for dispose the solid waste.
So based on your experience, you are able to see the difference of emissions?
Yes, because we design the route of transportation to reduce this greenhouse gas or emission from our transportation, because Nonthaburi is very closely to Bangkok, and now we have very traffic jam. And yes, we plan the routing and start to collect early, because it can generate less emission.
Yeah, and also final disposal.
Now we are disposed by landfill site, security landfill, and in the future, the Nonthaburi provincial we use incinerator to dispose solid waste. And I think the emission will such as methane or some emission can less than now.
And you also said like you also improved the processing. So what activities was improved?
Now especially transportation, we improve our vehicle and maintenance, especially for the organic waste. We used to composting the garbage from the market or some department store to reduce the waste to go to the landfill site.
Yeah. So Thank you. Thank you very much. So it is good to learn that the exercise, like you learn, especially from the training, regional training of EQT. So you are utilizing it for the improvement of waste management in Nonthaburi. So I thank you very much for sharing your experience. And I think we also, so thank you, Ms. Jirapon. Thank you very much.
You're welcome.
And I think we also might have participants from Medan City. So especially Medan City, they also developed action plan for reduction of SLCP using the EQT. So is there anyone anyone from Medan City? Could you please kindly raise your hand? If not, do we have Miss Yatin from Jambi City? If you are there, could you please raise your hand? Not there. No. So maybe you can proceed, Hassan. Yeah.
Okay.
Yeah. So
Thank you, Rajiv.
yeah. So I'd like to hand over to Hayashi-san. So she would like to proceed with the second part.
Okay.
Yeah. Thank you.
So let me share my screen.
Sorry, Ms. Mio-san.
Yes.
So I noticed one of our colleagues from Indonesia, Mr. Haneda, raised his hands. If he can possible to give opportunity for him.
Yes, of course.
Where?
Yes, thank you, Firdaus. Good afternoon, everyone. Thank you, Mr. Rajiv and Miho-san. This is Haneda speaking from Working Group of Environment. Especially, I'm delivered to Irawan that he is the Vice Director for responsible in inventory, GHG inventory. I just like to just simple question that Indonesia is currently has used the own method on GHG inventory. I'm wondering what the tier level that are used or being used equity in using in Padang or in other city in Indonesia, as I know that in using the tier level become higher level is more complicated data that has to collect. So if the cities of Padang or Medan or any other city can use using the tier level will be good, but I would like to know what will use in average in city Indonesia in quantify the emission will inventory. That's my question. Thank you, Pak Firdaus and others.
Didn't get it. Tier level.
For the technical aspect, we will provide the training next time. But the I'm sorry, tier level is we are not clear about the meaning of tier level.
Tier level meaning that the tier 1 is the lowest one. The method has to collect. For example, in quantify the emission in using the fossil fuel. in Indonesia, if we quantify the emission from using the fuel, just we collecting all the fossil fuel as used in every sector. We not identified what the technology are using, how long that the technology is operating. That is, we neglected the others factors such like that. But we only collecting how much the fossil fuel is used and multiply with the emission factor. That's my understanding in identify the emission from such emission source.
So, Hassan, let me answer this question. So, thanks, Haneda-san, for this very important question. So, in our case, I think this is, as your example, is something related to the transport. So, we go a little bit further because we use the amount of fuel they use for transport for vehicle. At the same time, we categorize the vehicles in their quality of the vehicle. So we have 4 or 5 categories level of the vehicles, like just a dump truck. So it is the vehicle with the new vehicles or the old vehicles, or either they are electric vehicles. So we categorize in that level, and we use that parameters also when estimating the emission from the transport sector. Not only the fuel the amount, but also the type of the vehicle that they use for waste collection.
And also the distance that
distance from the vehicle collected from the house to house, and then how far it's transport up to the landfill. Yes, that is. But in the most cases, so we are collecting the sample vehicles with the working with the city, and sometimes we estimate the overall emissions after getting some sample of vehicles.
Yeah. So my question is, how difficult in waste sector if we will use the higher level in quantify the emission for Padang city or in other city?
Actually, it is that is one of the issues in this exercise, because most of the cities don't have the data to feed the tool accuracy, and we work with the city in as I mentioned. So it's not just the collect the data. We work with city to build their capacity to collect the data and reporting them. And the couple of issues what we also find in is like when Dr. Raju mentioned. So this amount of waste generation, and the characteristic of the waste, and the number of vehicles collected, and how far the landfill, these are still okay. But when we're looking at the uncollected waste and how it's managed at the household level, some are it's just disposed, or some are it's burning. So that's how much percentage of waste is burning. So that kind of data is quite difficult in the cities. And for that, actually, we currently doing a survey in Padang also, with the Andhas University and Cambodia and Myanmar, selecting 3 cities to understand this open burning situation in the cities, with the sample regions in the city, and measuring, because currently it's depend on the percentage based on the interview with the city officials, or sampling, looking at how much waste is burning. We say 30% or 20% uncollected waste is burned in the city or not. So this is still have some kind of a difficulty in the data systems.
Meaning that the tier level will be still first level, or?
Yes, yes, we are working at the city level, at the first level. In the Padang, actually, we selected 5 what you call RK, RH. Yeah, so level. So we actually collected more detailed information in Padang in few this RTRW level. But the today results show by the Rajiv is the city level. It is a little bit easy still than the community level. We not still that level.
Okay, thank you. Clear.
Thank you, Ananda-san.
You're welcome.
Okay, so let's move on to the next presentation and question and answers. Since the time is running out, let me quickly go through it. So now I hope that most of the audience has understood what is EQT, how is EQT be used for, and also the definition of methane gas, or even I'm sure that you already know the GHG greenhouse gas, and also now you understood the SLCP, which methane also is included. So now you have understood all the issues and what will be the way forward from now on. So today's webinar, we were talking about the general aspect of the EQT and also GHG emission, SLCP emission calculator. So we would like to provide more detailed training, more focusing on technical aspect on EQT and its application to measure the emissions from the municipal solid waste management sector. So in the next training, we will be talking about what kind of data will be required to run this EQT, like the previous, related to the previous question, how difficult it is to, or how easy it is to collect such data, and then what will be the boundary of the system, so on. So we would also like to work together with the interested cities in quantification of their GHG and SLCP emission for the municipal solid waste management sector. We would like to assist cities in using the EQT results to make appropriate decisions on selecting appropriate technologies for future waste management. So by using these EQT tools, we can also help cities develop the future plans and policies. And then we would like to assist cities in monitoring and reporting the emissions from solid waste management to national for their NGC reporting using EQT tools. So of course, like the concerns from the Indonesian side, we also need to see how different it is between the EQT tools and the existing tool. So we may need to modify a little bit our tool, or we may need to look at the different aspects to utilize our tool or existing tool. So from now on, so this is what we would like to do, but we are not able to choose all cities who are interested in using the EQT tool as like a pilot activity. So we may need to select some cities to do to conduct these activities. But first of all, I would like to ask you, yes, if you are interested in applying EQT in your city. So there are 5 options. Yes, no, I need to consult with my colleagues or supervisors. I don't know, or not applicable. Oh. Yes. I am very glad that nobody says no. Yes, I understand that you may not be able to make final decision right now, but I am happy to see that many people answered positive way. Yes, most people say yes, or either yes, or I need to consult with your colleagues and supervisor. Thank you very much. Next question. What do you think about, what do you think would be obstacles to apply EQT? The first, data collection. Second, accuracy or data reliability of EQT is questionable. 3, conflict with IPCC emission tool. 4, EQT tool looks complicated and difficult. 5, no policy obligation to apply EQT. 6, others. Okay. 38%. Okay. Okay. I understand most people are concerned about data collection. Yes, this is something that we are going to talk about at the next training session. So you will see how difficult or how easy it is to collect data. As for the accuracy, actually, this is already approved. This tool has been approved by CCSC, and it has been also used as some colleague from the Philippines mentioned Thailand, sorry, mentioned that this tool has been already applied and utilized. So, okay, so we are going to get rid of these worries or concerns at the next training. Okay, question number 3. Does your city constantly collect waste data?
Yes.
1, yes, every year. Number 2, yes, only when budget is available. Number 3, yes, only when we are told to collect data by higher government. Number 4, no. Number 5, others. Okay. It's very good to know that many cities collect data every year. So it's very good that so those cities are able to monitor that the emission level every year. So which is really good result. Okay, then next question. Question number 4. What is the type of final disposal site in your city? Number 1, sanitary landfill site. 2, disposal site, which is like semi-controlled, buried with soil and then utilize cell. And number 3, dumping site, which is non-controlled. Number 4, we don't have. Number 5, I don't know. Number 6, not applicable. Okay. This is also quite good result. So most cities, I mean, the participants, where participants come from, have the sanitary landfill site. So this is controlled landfill site. So I guess the emission level is lower than those who have dumping site or non-controlled disposal site. Okay. Sorry, there is another more questions. No, this is, I have to choose. Sorry.
Screen wrap.
Yeah.
Question 5. What do you consider about open burning in your city?
Okay. What do you consider about open burning in your city? The poll is here. Number 1, the way to reduce waste going to the final disposal site. 2, the way to reduce waste to avoid paying collection fee. 3, the cause of air pollution. 4, the cause of black carbon emission. 5, the cause of methane gas emission. Or open burning does not occur, does not exist in my city. Okay. Yeah, this is quite like predictable answer. Maybe because you're most of them are from the government sector, so the answers are yeah, related to pollution or black carbon emission and methane gas emission. That's quite reasonable. But when it comes to the waste generator, they may, according to some survey that we conducted in Padang City, some waste generator citizen may answer that they burn the waste in order to reduce the waste generation. So that's a reality on the ground. Okay. Next question. Have you ever heard of short-lived climate pollutants before? That's the same question that we had asked at the beginning of the presentation. Have you heard about short-lived climate pollutant, SLCP, before? Before means
before the presentation.
Before I mean,
before the presentation, then
before my presentation.
Yeah.
So now I hope that you have some idea about the short-lived climate pollutants. Probably the way we ask question, I mean, it might not be yeah, correct, but yeah, like half people answer still no. Yes. Okay, this is also reflection question. Is methane GHG?
Question 9. Yeah.
Is methane GHG or SLCP? Okay, very good. So yes, both. Methane is GHG at the same time as SLCP. Thank you very much for understanding. And last two. Do you want to participate in the technical training on how to handle EQT? That's quite interesting question for us. Okay. Thank you very much. More than 80% of audience answered yes. Thank you very much for showing your interest. The last question. How was today's webinar? 1, informative, 2, too difficult to understand, 3, useful, 4, boring, and others. Okay, this is also good evaluation for us. Today's webinar was informative, at the same time useful. Thank you very much for your evaluation, Paul. Okay. So based on these answers, and we are going to plan the next training that will be also webinar type. So we are going to coordinate with the IMT center to then we will let you know when will be the next training. So if you also have some specific request, what kind of question that you would like to ask or to be included in a webinar, we're happy to hear that. So please share your opinions or requests with IMT Center. Thank you very much. So over to Mr. Ali. Yeah, Mr. Akil.
Thank you, Miho. Thank you, IG, for our discussion today. And then I would like to invite Pak Firdaus for his closing remark. Thank you.
Thank you very much, Fakir. First of all, I would like to thank our colleague from IGCGT, particularly Dr. Kumara, Ms. Miho Sang, Dr. Rajiv, and colleague as well. And also to our colleague, Chairman of MTGT Working Group Environment, Mr. Pafi, and all colleagues, participants, for this afternoon's webinar. I think that our webinar this afternoon is quite useful for us. It is very important for us, it is very useful, especially for the MTGT. As I mentioned earlier in my remarks in the beginning of this course, now MTGT has already the blueprint to achieve our GHG emission. So this is one of the important tools for us to achieve, and also to achieve, to assist our members of countries on the ground. We noticed as well, there's some question as well from the ground just now. This is also a good information for us. Basically, from the questionnaire circulated by our colleague from IGCCET just now, we can also monitor that, yes, we need to assist also our member state in terms of the data collection. That is the importance element as well, in order to use the tool of equity. So, dear colleague, I think this is the first time for us to conduct the webinar with IGCT, as mentioned by our colleague Miho Sang as well just now. So we hope that we can continue for the next step to conduct training for our members of IGCT how to use the equity tool to assess or to quantify the GHG or SLCP emission reduction. So from our office, CMT, Putrajaya, and also on behalf of all my colleagues, MTGT, I wanted to thank you, IGCCET, for your assistance, great assistance to MTGT in this webinar. I do hope that the next cooperation. We notice as well from our member state just now from the participants, maybe they need as well some kind of the separate discussions, on the equity, how compatible the equity is with the existing tool they have on the ground as well in member state. So I think that we will follow up this with our member state as well. So we would like to request to our member state of this webinar, please email us for any kind of assistance. Let's say for this, that if you consider that separate session needed to know further about the equity, or another suggestion that we are going to do need to be done for the next, please also email to us through CIMT. And of course, we would like to communicate with our partners, with our colleague in IGCCET. So thank you very much again for your participation. And from our office in Putrajaya and our team, thank you very much. And see you next time in the next activities between CIMT and TGT and IGCCET. Thank you very much. Have a very good afternoon again, and have a good rest. Thank you very much.
Thank you very much.
Thank you very much.
Thank you very much.